Lesson 1.4 is all about the standard form of linear equations. This one follows our last two lessons because we're going to go over a different form of linear equations, so not our slope-intercept form, which remember was y equals mx plus b. This is going to be a little bit different, and we're going to go over how to change it back into a slope-intercept equation, the y equals mx plus b. So let's look at first our key terms. A couple things I want you to highlight or underline. Standard form, a linear equation of the form ax plus by equals c. Now to be true standard form, a has to be greater than or equal to 0, which means it has to be positive. A and b are not both 0, so you can't have 0x plus 0y equals some number. Okay, that just wouldn't make sense. A, b, and c are all integers with greatest common factor of 1, which means you can't have fractions on these. And let's say it was like 2, 4, and 8. Well, that doesn't make sense because you could divide all of those by 2 and make it smaller. It'd be 1, 2, and 4. Okay, so you always want them to be the smallest integers you can possibly make. Okay, ax and by are the variable terms. C is going to be a constant term. Okay, so c is just a number. This is going to have some number. It might be a, well, this one has to be positive, so some number times x. This would be some number times y. This one could be positive or negative. Okay, so could c actually. C can be positive or negative, but it's just a number, no variable with it. Okay, the x-intercept is the x-coordinate of the point at which the graph crosses the x-axis, also called the horizontal intercept. The y-intercept then is the y-coordinate of the point at which the graph of an equation crosses the y-axis, also called the vertical intercept. Note, usually lines will only have one x-intercept, one y-intercept. This is different only for y equals 0 or, write this in as well, x equals 0. These ones are special because if you had the line y equals 0, that's a horizontal line on the x-axis. That means every single point is an x-intercept because every single point is on the x-axis. Same thing with x equals 0. Every single point on that line is going to be on the y-axis. Okay, so they're all y-intercepts. Okay, so those would be the only differences. To find intercepts of a linear equation, you literally just plug in 0. Okay, so to find it for the x-intercept, plug in 0 for y. To find the y-intercept, plug in 0 for x. All we're doing is just plugging in 0 and solving out for what our variable becomes then. To rewrite our standard form linear equations into slope-intercept form, you just solve the equation algebraically for y. Get y alone. What I want you to write here is literal equations. I'm just going to write literal. If that's all you need to write, that's fine. This is what we did in our last lesson. The literal equations, we're always solving for y, getting y alone. So, in the following examples, we need to find the x and y intercept of the line, and we're going to rewrite it into slope-intercept form. So for our first example, if we want to find our x-intercept and our y-intercept, remember, we're just plugging in 0 for each of these. Notice, x-intercept, we've already plugged in 0 for y. Y-intercept, we've plugged in 0 for x. This is the equation we're starting with, x plus 3y equals 6. Now notice, in this case, I'm going to write in that there's kind of a hidden 1 here. Our a is 1, our b is positive 3, our c is positive 6. ax plus by equals c. So this is standard form. Now, to find our x-intercept, we plug in a 0 for y. To find our y-intercept, we plug in a 0 for x. So that's going to look something like this. Okay, so it would be x plus 3 times 0, not 3 times y. We plugged in 0 there, equals 6. Well, 3 times 0 is just 0. X plus 0 is the same as just saying x, so x has to be 6. So our x-intercept is at 6, 0. Our y-intercept, we're just taking that 0, plugging it in for x. So 0 plus 3y equals 6, which means 3y equals 6. To get y alone then, you would be dividing by 3 on both sides of the equation. Cancel out that 3, and we'd have y equals 2. So here are x and y intercepts. 6, 0 is our x-intercept, 0, 2 is our y-intercept. Now, to get it into slope-intercept form, we start with this equation, and we work at trying to get y alone. It's going to look something like this. Oops. Here we have our equation, x plus 3y equals 6. Now again, like our literal equations, we're thinking what's happening to y? So I might write that over here. We start with y. First thing we're doing is times 3. Oh, maybe I'll use a little multiply sign. Then we're adding on x. And in the end, that is going to be equal to 6. Working our way backwards from 6 to y, trying to get y alone. We're going to do the opposite of everything that we encountered. So instead of plus x, we would minus x. Instead of times 3, we would be dividing by 3. But we have to do it in the correct order. So subtract x first from both sides. It's going to look like this. We get rid of it on this side, and we call it 6 minus x, which again we can rewrite as negative x plus 6, just rearranging and keeping the variable first. Now we have to divide everything by 3. It's going to look something like this. Now again, remember that this kind of means the same as saying y equals. We had negative x plus 6, and we divided it all by 3. Okay, that's how we went from this one to this one. Now, a couple things here. There's a hidden 1 right here because there's no number. We always know it's a 1. So it's like negative 1x plus 6. This divide by 3 can be distributed to each one of these. Division and multiplication are the things that can be distributed. If we distributed this divide by 3 to this term, it becomes negative 1 over 3. Okay, that's where this came from, was distributing the 3. Same thing. 6 divided by 3, distributing the 3 out, becomes the plus 2. This is now our slope-intercept equation. Okay, notice how the intercept, our y-intercept, positive 2, that's exactly what we found here. So it fits in perfectly. Our slope then is negative 1/3, meaning go down 1 and over 3. Let's go on to another example then. We're going to find the x and y intercept, just like we did before, and rewrite into slope-intercept form, just like we did before. In this example, we've got 2x minus 3y equals 15. So again, ax plus by equals c, standard form. To find our x and y intercept, we're plugging in zeros again. So plugging in 0 for y, which is going to cancel that piece totally out. So it's 2x equals 15. Divide by 2 on both sides. You can either say x equals 15 halves, because 15 over 2, or if you'd like it as a mixed number, you would do 7.5. Or I guess you can call it 7.5, whichever one works best for you. You know what, just because I don't have this one written on there, I'm going to call it 7.5 as the decimal version. Okay, now for our y-intercept, same thing, just plugging in 0 for x. Anything times 0 just gets canceled out. This minus 3y makes it become negative. It's a negative 3y. Okay, remember that. If it helps you, think of Smedo. This is like saying plus negative 3y. So we get rid of those, and now we have negative 3y equals 15. We have to divide both sides by negative 3. Not just 3, negative 3. Positive 15 divided by negative 3 becomes a negative 5. So that should go there. Again, to put it in slope-intercept form, start with the regular equation. Okay, now we're thinking about what's happening to y as we work towards getting it alone. The first thing that's happening to y is it's being multiplied by negative 3, not just 3, it's a negative 3 because of this minus. Then we're adding 2x. So to work backwards, we have to subtract 2x from both sides. That would get rid of this one. And put a minus 2x over here, a negative 2x plus 15, This is positive. Now, to get y alone, we're dividing by -3. When we do that, it gets this part away. -2x divided by -3. Well, the two negatives cancel, makes it positive. And now it's just 2 over 3. That doesn't reduce, so we'll leave it as 2/3. On this one, though, positive 15 divided by -3. The positive and the negative make it negative, or you can consider it minus. 15 divided by 3 is 5. So here's our slope-intercept form. Positive 2/3 x minus 5. Again, recognize minus 5 or -5 is exactly what we had as our y-intercept before. So it fits in perfect. Let's go on to example 3. In this case, we're going to be finding the x and y intercepts, rewriting it into slope-intercept form, and we will graph it. So this is just one extra step. We're graphing it at the end. So we have x minus 4y equals -12. If it helps, think of it as a 1 out front here. So a is 1, b is -4. I'm going to show you that it's add -4. Do that in red. So even though it said minus, we can call it adding -4 equals -12. Okay, to find our x and y intercepts, we just plug in 0 each time. When we plug in 0 for y here, those cancel out. So x, or 1x, equals -12. So we know for sure, okay, -12 is our x-intercept. When we're plugging in 0 for x to find our y-intercept, that goes away. Remember this minus 4y, we just said it's like adding a -4y. So -4y equals -12. Divide both sides by the -4. Negative divided by a negative is positive, so y equals 3. So we're going to have -12, 0 is our x-intercept, and 0, 3 is our y-intercept. I'm actually going to plot those points right now. Here's our y-intercept at 3. Here's going to be our x-intercept. It's going to be way over here off the chart at -12. Okay, we should be able to graph this already, but let's put it into slope-intercept form first and see if it fits. So, to do slope-intercept form, start with what we had. Okay, then again, we're thinking what's happening to y and working backwards. So it's y times a -4, then adding on this positive x. So to work backwards, we subtract x from both sides. That gets rid of x here and puts a negative x here. So -4y equals -x minus 12. Now we divide both sides by that -4. Because we're dividing by a negative, this negative and this minus become positive and plus in each case. It was like a 1x before, so it's 1 over 4. So 1/4 x plus a positive 3. So looking at our slope-intercept form, what is this saying? It's saying every time we go from one dot to another, it's up 1 over 4, up 1 over 4. And where does it hit the y-axis? At 3. Well, we already found that. It's at 3. Let's work from left to right, and we'll go up 1 over 4, puts us right here. Up 1 over 4 puts us here. Up 1 over 4 puts us right here, where we should hit. Up 1 over 4. So it looks like our two dots here fit in with our slope, and our full equation, actually. And now we just plot out our line. And there we have it. So we have our two intercepts, slope-intercept form, and we've graphed the line. Go on to example 4 then. Okay, we're going to do the same thing as we've done in the past few. The only difference here is we have it set equal to 0. So this might make things kind of interesting. Plugging in 0 for y. Again, we'll basically just use a different color. Cancel that out. So 5x. Oops, this should say 0. I don't know where that came from. 5x equals 0, which means that x has to equal 0. Okay, that means we have 0, 0 right here as our x-intercept. Plugging in 0 for x, we get 5 times 0, goes away. Minus 2y, or remember that's a negative 2y in a sense, equals 0. Divide by negative 2 on both sides, y equals 0. Which means that same spot is our x and our y-intercept. Okay, so the trick here is every time you have this set equal to 0, you know that both the x and y-intercept have to be right at the origin, that 0, 0 spot. Now we work on changing it to a slope-intercept form. Start with the equation. Think about what's happening to y. It's being multiplied by negative 2, then adding positive 5x. So we subtract that 5x from both sides. 0 minus 5x is a negative 5x then. Now we have negative 2y equals negative 5x. Divide by the negative 2 on both sides. Negative divided by negative cancels out. 5 divided by 2 becomes a 5 halves. So y equals 5 halves x. We don't have two intercepts to connect here, so we can't plot it just from our intercepts, but we have a slope-intercept form. Y equals mx plus our b value is 0. And we knew that because here it is, 0. So 5 over 2 means go up 5 over 2, up 5 over 2, which means our line is going to look like this. So we have our intercepts, our slope-intercept form, and our graph. One last example. In this case, we have 2x minus y equals negative 3. Like before, to find our intercepts, we plug in 0. Plugging in 0 for y cancels this piece out. It says 2x equals negative 3. Divide by 2 on both sides, x equals negative 3 halves. Put that right there. Or again, that's kind of like saying negative 1.5 if you'd rather do the mixed number. So negative 1.5 right here is our x-intercept. Our y-intercept, we plug in 0 for x. That cancels out. 0 times anything is just 0. So negative y equals negative 3. Divide both sides by negative 1 to cancel out those negatives. And we just have y equals 3. So 3 is our y-intercept, and that goes right here. So, switching it over to a slope-intercept equation, we have 2x minus y equals negative 3. If it helps, remember this is like a minus 1y or a negative 1. So we're saying y is being multiplied by negative 1, and then we're adding this 2x at the end. Okay, so to work our way backwards, we need to subtract 2x from both sides. So negative 1y, or just negative y, equals negative 2x minus 3. And then divide by that negative 1. We'll get it all by itself. So y equals 2x plus 3. This plus 3 fits in with our y-intercept. This 2x, remember, think of 2 as being 2 over 1. This fraction is the same as the whole number 2, which means go up 2 over 1, up 2 over 1. So from here, it's up 2 over 1, up 2 over 1, up 2 over 1. Working your way backwards, it would look like this. Down 2 over 1, down 2 over 1. And that only fits because these red dots go up 2 over 1, up 2 over 1. Oops. Those need to be 1 up. There we go. Now it fits. So that still makes a straight line going up 2 over 1, up 2 over 1, and it goes through that spot 0, 3. So it fits that equation. Now as we connect our dots, we've graphed our line. And that should cover it for example 5 and our video.